Hello, welcome. In this video, we are going to go over static equilibrium practice questions. Okay, so the question are going to come from the UNZA tutorial sheet 8, which is static equilibrium. Yes, okay. So we are going to start with question 1. So question 1 is saying the system in the figure is at equilibrium when M1 is equal to 10 kg. Find the values of tension 1, tension 2 and M2. Assume the pulley to be massless and frictionless so that it does not change the tension in the code. Okay, so as you can see, this is the question 1 from UNZA tutorial sheet. Okay, so we have even been given the marking key to see if we have gotten the right answer. Okay, so first and foremost, let's look at the setup of the diagram. So the diagram has been drawn for us. Okay, so we have tension 1. Okay, sorry, tension 2. We have tension 1. We also have M2. So our main focus is to find tension 1, tension 2 and and mass 2. Okay, so what are we going to do for us to find this tension and the mass? Okay, so now we are going to look over summation of tension in the x and in the y in terms of components. Okay, so let's try to look at this situation in terms of a free body diagram. So let's try to take this situation here as we have a point. Okay, so this is the point which is here, the center. Okay, so we have tension 1 which is going this side, and we have tension 2 which is going that side. Okay, so we have also the weight which is going that side. Okay, sorry about the drawing. Okay, so we have tension which is going so let's name this one as a T1, then this is our T2. Okay, and this is our weight force, so it's going like that, that's and that. Okay, so now we've been given angles, so let's for us to solve this problem correctly, let's try to see what is happening in terms of a Cartesian plane. So we can draw a Cartesian plane, we extend that part. Okay, we even extend this part. Okay, let me use a different color. We extend that part. So we have this angle here and we have this angle here. We've been given the two angles. Okay, so in terms of vectors, we can say this angle is 45, just as we have been given 45, and this angle here, it is 53. Okay, so we have this angle and that angle. Okay, so now let's try to look at this situation in terms of components. Okay, so we can try to look at this tension which is going this side in terms of component. So this is our tension. Now let us look it in terms of its component. So this tension 1, we are looking at tension 1. Let me use a different color. Okay, so we are looking at this tension here. Okay, so we are saying this tension here, it has two components, which are saying it has this component which is the x component, and we also have this component which is the y component in terms of T1, even this one T1. Okay, so we have this component, these two components of this tension. Okay, so now let's try to look at the other one, which is T2. Let's try to look at the component which it has. Okay, so now we can see that, sorry, okay, so we can see that even this one has the x component, and it has the y component which is going in that direction. Okay, so it has two components which is going in that direction. Sorry about the drawing. Okay, so here's the thing. So we have ty, so we have t2y and t2x. So we have those components there. So now let's try to look at this system. This one, as you can see, the weight force, the weight force which is having the mass 2. So the weight force, we can see it is just along the y-axis. And what do we say if it is along the y-axis? We say that if it is along the y-axis, it is possessing a 270 degrees. Okay, 270 degrees. So meaning starting from here, that's the angle it is having from here to there. Okay, okay. So we have seen it has an angle that side. Okay, so now what we are going to do, we are going to sum the forces in the x and the forces in the y. They should be equal to each other. What do I mean? When I say they should be equal to each other, we are saying if you sum, we sum forces in the x, they should be equal to 0. Okay, so let us try to sum up the forces in the x. So uh, we are saying t2 t2x, okay, t2x, which is on the negative side, t2x, which is on the negative side, should be equal to t1, sorry, let me erase that part. Okay, we are going to add it. If we say add uh, t1x, they should be able to give us a what, a 0. Okay, so if you add t2 and t1, they should be able to give us a 0. So what do I mean? This one can go to the other side, so just to get rid of the negative. So here we are going to remain with t1x is equal to t2x. So t1x is equal to t2x. Okay, that is in terms of x component. Okay, so we can try to look at in a detailed manner to say t1 cos theta should be equal to t2 cos theta. Okay, so this is our equation 1. So that is our equation 1. So let's try again to look at the situation, what is happening in the y direction. Okay, so in the y direction, if we try to forget about this thing, let me do this. If we try to forget about this thing, we just remain with what is happening in the y. So in the y, as you can see, we have two forces which is going up and one force which is coming down. So in this case, we are going to say if we sum up t2y plus t2 sorry, t1, not t2. Okay, let me just erase. So this is T2. T2. Okay, I made a mistake. T1. Why? If we sum up this one, then if we subtract the weight force, they should be able to give us a 0. Okay, what does that mean? If we subtract this weight force from these two forces which are here on top, they should be able to give us a 0. So what do I mean? So let's try to get rid of the negative part. T2y plus T1y should be equal to the weight force. Okay, so let's try to look it at in terms of detailed manner, where we say um, we say T2y is the same as T2 sine theta plus T1 sine theta is equal to what? The weight force, we know that the weight force is equal to mg, so it can just simply be equal to mg. Okay, so now we have come up with equations. We've come up with these equations. So now let's try to simplify them now to see what we don't have and what we have. Okay, so here we can say T1 cos, what's the angle for T1? It is 45. Equals, what's our T2? We don't know. What is our angle for T2? It is 53 degrees. Okay, so here we can try to simplify it. What can we say? We can say T1 cos 45. So if you just say cos 45, what's the answer? It's giving 0.707. So here we can just say 0.707 T1 equals, what about the other one, which is cos 53? Cos 53, it is giving 0.60 18. Okay, let's just keep it to 2 decimal place. Is it 3? 3 significant figures. So let's keep it to 3 significant figures. So you can say 6 0 2. Okay, so that is our T2. Okay, so this is our expression 1. This is still our expression 1. Let's go back to this one. What about this one? It is T2 sine, what's the angle? The angle is for T2 is 53 plus, what is our T2? T1 we don't have. Then we say sine, what's the angle? It is 45, is equal to mg. So in this case we don't have to do what? We don't have to waste time in putting mg. We can just let it to be w the way it was for now. Okay, so now let's simplify it. So we say sine 53, so T2 sine 53, so it's giving 0.799. That is our T2 plus what is our T1? We don't have. T1, then sine, what is, let me do this, sine 45, sine 45. So it's giving 0 point, it's giving 0.707 T1 is equal to W. Okay, so now we have these two expressions. So now, as you can see, we need to find how many variables here. We need to find the tension and the weight. Okay, so now in this case, as you have seen, it is very impossible for us to calculate the two at the same time. We can't solve them simultaneously unless they were two. Now in this case, what can we do? Okay, we can go back to the diagram. What's the diagram saying? So the diagram we have here, as you can see, it went that side, then it has something that side. Okay, so it has this object which they said it is 10 what, 10 kg. Okay, so we have enough data. Since we know that this weight force is going to be equal to the tension force, because the tension in the rope, as long as the pulley is massless and the is frictionless, the tension here is the same as the tension here. So now we can choose to calculate for the tension here. Okay, so we know that weight force, that weight force which is here, weight force, we can say weight force is equal to what, mg. So what is our m? It is 10 kilogram. So now what is the standard SI unit for mass? It is, if we talk of physics, it's just kg, like that, not as in chemistry where we say it's gram. So here we're going to use the way it is, 10 kg multiplied by 9.8. So the weight force is giving us what, 98. If we multiply 98, what, 98 newton. So in this case, since we know that the weight of that object is equal to the what, is equal to the tension 1. Okay, so our tension 1 we have so far, it is this one. That is our tension 1. So now we have more data now, such that we can calculate for any variable here. So let's start plugging in what we should have and what we don't have. So we can say, since we have our tension 1 as 9.8, we can say 0.707 multiplied by 98 should be equal to 0.062 T2. Okay, so now here we multiply now 0.707 multiplied by 9.8. What's the answer? The answer is giving 6.9286 is equal to 0.602 T2. So over 0.602 over 0.602. So we can say our T2 is equal to, so if we say 6 divided by 0.602, what's the answer? It's giving something like okay, just a minute, we say 6.9 2 okay, 9.8 okay, 9.8 . sorry, 98 point multiplied by 0 707. Okay, so as you can see, there was a slight mistake here. Let me erase that part. There was a slight mistake here in our calculations. I hope you spot that out. Okay, so here it was supposed to be 69.286. So we divide by the same 0.602. So our T2, we are saying it is equal to what? The same value, we divide by 0.602. Okay, it's giving 15.09 Newton. Okay, so far we have calculated our T1, which is 98 Newton. That is our T1, and again we've calculated our T2, which is 115.09. Okay, 0.09 Newton. Okay, so kindly note that there can be some slight difference because of the value using. Okay, so when you are solving as in terms of exam tests, you need to write the O value without rounding off. You need to round off at the final answer as so as to get the same value as they have. Okay, as the required value. To get the exact value, you need to not be rounding off. You need to be writing the O value. If at all you have 20 significant figure, you need to get it. You need to get them O, not like rounding off, so as to get the actual value. So as you can see, there will be a slight difference in terms of the answers because of the rounding off part. Okay, so now without wasting much of the time, let's go to the last part. We calculate the mass which we are being asked for. Okay, so we are now on this part. Okay, let me use the different color. We are now on this part, M2. So this weight is the one which is going to provide with the mass which they need there. Okay, let's try to create some space. Okay, so let's create some space. Okay, so we are going to use this equation here to calculate what we need. So we have 0.799. What is our T2? Our T2 we've calculated as in 115.09. Okay, 115.09. We're going to use the same value which we've calculated, but kindly note, even here you need to put the actual value, the actual number of numbers which were in that figure, not like rounding off, for you to get the exact value. Okay, plus 0.707. Okay, what is our T1? Our T1 we've calculated as 98. Okay, is equal to the what? To the weight. So if we punch in everything there, which is 0.799, okay, 99 multiplied by 15, 115, okay, 0.09, okay, plus we say 0.707 multiplied by 9.8. Okay, sorry, 9.8, 98, not 9.8. Okay, so we are getting 161.24. Hope you have a calculator there. You are able to spot out the mistake which can be made along the way. So now this weight force, we know that it is mg. So we can now replace here as mg. Okay, so now the gravity, we know the gravity which pulls anything on earth downward, it is what? 9.8. so we can say over gravity, so that our m should be equal to the same value, which is 161.24291 over 9.8. so if we divide that one by 9.8, we are going to get 9.8. so we are getting, so if we do that, we are getting 16.45. That is in kg. So that is in kg. Okay, so we can round off to the required significant figure if at all they asked for it in the question. So our mass 2 is equal to 16 point, we can say 5 kg. So this is our answer. So as you can see, if we compare our answers with that which one, the one which are in the tutor sheet, they are the same. So we can say we are in the right path. So this is how we solve static equilibrium question involving pulleys. If they ask you to find the tension, you just need to sum up the tension in the y and in the x, equate them, and solve them simultaneously, as simple as straightforward. Okay, so now I'm going to leave you with a certain question which will come and solve in the next tutorial. Okay, due to our limited time, we are going to solve it in the next video, not this one. Okay, so you can try it out before we come and solve it. Okay, so here is the question. So you are going to solve it in a similar manner as we have solved that one. So you are going to compare our answer in our next tutorial. Just stay tuned and subscribe to our channel, Transcended Institute. Okay, so we have a lot of videos on our channel. You can try to watch, subscribe. Just visit, or in the description there will be a number which you can contact us on WhatsApp. Yeah, so that is it for today's video. Just stay tuned. Okay.